Musa. I am going to deliver my lecture on the topic optical rotation and also pronounce theory and experiment about optical rotation. So today first we are going to see what is called optical rotation. So we know that according to the theory of polarization of light, when an unpolarized light enters into a polarizing medium. So here we have taken two equal prisms. One is N1, another one is N2. So this prism will act as the polarizer and the next prism will act as the analyzer. So in case of theory of polarization, when the unpolarized light enters into the polarizer, it will become a polarized light. So when that light enters into the analyzer, we can analyze and check whether the light has been polarized by this polarizer or not. But in this case, there is a challenge here. So the thing is, both the prisms are crossed. So you can see from this diagram, both N1 and N2 prisms are crossed. So the reason here, the thing is, when the unpolarized light enters into the polarizer, light comes out of polarizer will be a polarized light. But since the N2 prism is crossed, it cannot enter into the analyzer prism. Okay. So, but if we use the optical activity, which is the property of rotating the plane of vibration of polarized light by a certain distance. So this property is used to enter this light into this analyzer, even though both N1 and N2 are crossed prisms. So we are going to see how we can use optically active substances to rotate the plane of vibration to make this combination useful. Okay. So as we can see, we have placed an optically active substance in between the polarizer and the analyzer. So here we can observe when the unpolarized light enters into the N1 equal prism, polarized light is coming out of the polarizer and it is actually optically rotated by this substance, which is called as optically active substance, which is acronym here, that is OAS. Okay, it stands for optically active substance. And the light coming out of the optically active substance will be able to go through the second prism. So finally we will be getting plain polarized light as the output. So this is how optical activity works. So as we can see, the plane of polarization inside this optically active medium is actually rotated by a particular angle. Okay, that angle we call it as angle of rotation. So there are two types of rotation which can happen with the help of this optically active substance. The first one is extrarotatory, which is called as derotatory. Okay, in derotatory, this light plane of polarization, it will be rotated on the right side. Okay, that is called as derotatory substance. And for example, we can take cane sugar solution. So this solution is an